Hey, it's Mr. Stoletano, and this video is going to explain density. So there are a couple things you want to make sure you're listening for as we go through this density video, and you want to make sure you have known by the time the video is over. The first thing is you want to be able to quantify density by applying the density formula. So you want to have the formula to calculate density committed to memory by the time this video is done. You also want to become comfortable with the units for density. So the units for density are unlike anything you've ever dealt with, and you want to get some practice in to make sure that you're comfortable with using those units and using them correctly. And the last thing is you want to be able to relate density to the substance's identity. So if we have an unknown substance that we just picked up off the street and it's pure, and we want to figure out what it is, we can use its density to do that. And so those are the things you want to be listening for as we go through. So let's start off density. Before we even get into anything, what do you think of when you think of density? So you probably think of maybe that if something is more dense, it sinks compared to something less dense, right? So the bottom of this density column, for example, the honey is the most dense of all these liquids, right? And so the honey sinks. And you might also think, okay, well, the lamp oil is the least dense, and so that's why that's at the very top. So that might be one way that you think of density. Another way that you might be thinking about it already is just how thick something is, right? So you think something dense, you might think, wow, that thing is really thick. And you can use your intuition to kind of tell, looking at these two cubes, which one is the more dense of the two. So which one of these do you think is more dense? So the one on the right is more dense, but why do you think that is? How did you figure out that that was more dense? Well, the one on the right obviously has more things packed into it, right? And so we can actually use that to develop our definition of density. So the definition of density is the ratio of mass to an object's volume. So you decided in your head that this one was more dense because there was more mass packed into a certain amount of space, right? There was more matter packed into a certain amount of space into a certain amount of volume. And so that's what density is. Now, what's a formula that we can actually use to calculate based on this? Well, the formula works the same way. So the formula is the mass of a substance divided by the volume that substance takes up. So it's really a ratio of how much mass is in a certain amount of space. And so we use this to do our calculations. There's a couple ways that you can remember this. The first one is that you're about the age now where you're going to be getting your permit, right? And so you can think of it as the DMV, the driver motor vehicle. As long as you remember that it's M over V. So density equals mass over volume. Driver motor vehicle is one option. Another option you could think of to help you remember this is that density is like a broken heart. What does that mean? Well, remember the formula for density is mass divided by volume, and that looks a lot like a broken heart. So if we look, the part on top of the line here for the heart looks like an M, like the letter M, right? And then the part on the bottom looks like a V, the part on the bottom of the line. And then the line is breaking the heart there. So density is like a broken heart. Okay, so this definition makes a lot of sense, and this formula makes a lot of sense based on this image, because the less material, the less mass is packed into a certain volume, like what we see here, the less dense, right? So the numerator would be very tiny in this case. In the other extreme, the very dense part, there's more mass packed into a certain volume. The numerator would be much bigger if we kept the denominator constant, right? So the mass part would be much bigger, and that's why the density is higher. If you're dividing a bigger number by a small number, you get a high number, right? So that makes a lot of sense for our formula. Okay, so let's get some practice in so that we're sure we know how to work with this density calculation. So here is a box, and we want to find the density of this box. So first thing we have to think of is our formula, right? So what's our formula again? So the formula is density equals mass divided by volume. So if we look carefully, we're given the mass. So that's pretty nice. That's already given for us. But what are we missing, though, from our formula? So the thing that we're actually missing is the volume, right? How would you determine the volume of a box? What formula would you use again, given these three dimensions that you have? So you probably realize the formula that you would use is length times width times height, right? So 8 meters times 6 meters times 6 meters in this case would give us our volume of our box. So take a minute to calculate that. What do you get for that? So the number that you would get is 288, right? But here's kind of the odd part. What units would you get for that? Keep in mind that you multiplied meters times meters times meters. So what's a unit of volume that you use when you multiply them like that? So that unit would be meters cubed, which is a little bit different from what we're used to, right? Okay, so now we have our mass and our volume. We're ready to do our calculation. Mass must go on top, don't forget. Not the volume, the mass goes on top. So the mass of 600 grams goes on top. The 288 meters cubed goes on bottom. And we do our calculation. And what number would you get during this calculation? What would you get for that? So you should have gotten this, right? 2.083 repeating. And here's the harder part. What would the units be? This is a new thing. What would the units for our density be? Well, the units are actually just like what was in the calculation. It's the grams divided by meters cubed. And it's always going to be something like that. It's always going to be some unit of mass slash some unit of volume, because that's the calculation that you do. And so in this case, we have our grams slash meters cubed, and we represent that with our number by grams slash meter cubed. So these are the units for density. It can't just be grams, it can't just be meter cubed, it must be grams per meter cubed. Is that density? So here we have a couple of boxes, and we want to determine their cubes actually, and we want to determine the density of each of them and then kind of compare them. So given that it's a cube, how would you figure this out? Well, the key is that all sides of a cube are equal, right? And we're given that this cube has a 3 centimeter side. So we can use that to determine the volume. So given that, what would the volume of this cube be, given that all the sides are equal? So you would use that, and you would say, well, I do 3 centimeters times 3 centimeters times 3 centimeters is going to give you my volume. And that's going to equal what number? 27 centimeters cubed, right? Again, we cubed the centimeters in this case. Okay. And now we have our mass as well, which is 81 grams. So we do our mass divided by our volume, which is then going to give us what value for density? Now be careful with this. What value would you get for density here? We would get 3, and then the units this time are grams per centimeter cubed, because that was our unit of volume that we did, centimeters cubed. So that's what you would get for that. So take a moment, given what you know now, to solve the next one. How would you get the next cube? Find the density of the cube. So what you should have done is taken that side of 8 and cubed it, right? So that's where that term comes from. Cubing something is because 3 sides of the cube, the lengths of the cube are equal, and so you can actually take it to the third power to determine the volume. And so this is what you would have gotten, and your number would have been this for volume, 512 centimeters cubed. And then you would have taken the mass and divided by that volume, and you would have gotten the same density. So that's interesting. These cubes look very different from each other, but they have the same density. What does that mean? Well, that probably means that they're made of the same material, because if something has the same density, it's more than likely made of the same material if it's a pure item. It's also interesting to think about this, because if we look, this cube is much smaller than this cube, right? But it still has the same density, and that's because density is a ratio, right? So even though this mass is much smaller than this mass, this volume is also much smaller than that volume, and so it's a ratio of mass to volume. It's a proportion, right? So a small mass divided by a small volume can be equal to a larger mass divided by an equally larger volume. It's proportionate, and so the densities are the same. Okay, one last problem. So we want to calculate the density of this box, and then once we found that density, we want to look at our chart to determine what this box is actually made of. Because remember, you can use density to identify a substance. You can use density to find out exactly what you're handling. So take a moment to figure out the density of this item, and then we'll compare to the list. Okay, so if you did this correctly, you should have gotten for your mass 270 grams. Your volume should have been 100 centimeters cubed, because 10 centimeters times 5 centimeters times 2 centimeters is going to give you 100 centimeters cubed, right? Then we do our mass divided by volume, never the reverse. So 270 divided by 100 is going to give you 2.7 grams per centimeter cubed. Remember, that's our units for density. Now we find this on our table, and what exactly must our box be made of according to our table of densities? So you should have found that our box is made of aluminum, because the value of aluminum is 2.7. What are the units for that 2.7 according to our table? So we should have gotten that the units are grams per centimeter cubed. So that does it for us. Thank you for watching, and remember, chemistry is everywhere.